Unexpectedly, galactic events of extraordinary scale happen billions of kilometers from Earth, reverberating all through the universe. By and by, a tantamount event is moving toward, causing shock even among scientists. A red giant star, organized at the outer ranges of our system, is conveying ominous signs. Across the universe, caught by the James Webb Space Telescope, cosmologists have revealed significantly upsetting exposures about this legendary sublime body. As perceived astrophysicist Brian Cox gives a grave counsel, a pressing question arises. Are we faltering on the edge of seeing a grievous, enormous blast that could everlastingly change the normal night sky? Before diving into extra nuances, try to subscribe to our station if you haven't already. Now, the burning question holds up. Will this impact Earth, and will it be recognizable from our planet? Stay tuned as we explore the responses to these convincing requests in this video. In the gigantic range of the universe, where the demonstration of radiant birth, life, and death unfurls in hypnotizing marvel, one specific star has, as of late, coordinated the consideration and worry of both cosmologists and the general public. This star, referred to as Betelgeuse, stands out discernibly as a red supergiant in the constellation Orion, parading epic size and age. While its striking rosy shade and fluctuating splendor have long fascinated spectators, late events have also elevated revenue in this glorious behemoth. As we dive into the quintessence of Betelgeuse, we find ourselves approaching the very edge of a potentially tremendous event in the star's life cycle. Yet, what do these changes in Betelgeuse's behavior mean? Could we witness the beginning of a momentous, pretentious display of unimaginable scale? Betelgeuse, displaying a size approximately 1,000 times greater than our Sun, remains a monstrous giant among stars. Its sheer size extends the limitations of human imagination. Picture a star so colossal that if it were to assume the Sun's position, its surface would grow past Mars' orbit, wrapping Mercury, Venus, Earth, and Mars within its magnificent handle. This remarkable size highlights Betelgeuse's true monstrosity, as well as signals its spot in the stellar life cycle as a red supergiant. Betelgeuse is in the twilight of its existence, marked by extension and cooling after millions of years of combining hydrogen into helium at its core. Questions arise about Betelgeuse's age. Regardless of being relatively youthful in human terms, estimated at around 8.8 to 8.5 million years old, it remains very old within the context of cosmic lifespans. Its current status as a red supergiant reflects the climax of millions of years of cosmic evolution, characterized by significant changes from a hot blue star to the giant red star we observe today. The journey of stars like Betelgeuse unfolds as a story of continuous transformation, driven by the determined powers of atomic fusion and gravity. One notable feature of Betelgeuse's current stage is its striking red tint. This dark red hue arises from its relatively cooler surface temperature. Unlike stars like our Sun, which shines at around 5,500 Kelvin, Betelgeuse's surface is cooler, starting at around 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light in shades of red. However, this color isn't merely an aesthetic trait. It provides insights into the star's actual state and the ongoing processes within its massive gaseous envelope. Adding to the intrigue surrounding Betelgeuse is its strange color history. Ancient works from Roman and Chinese sources suggest that nearly 2,000 years ago, Betelgeuse appeared yellow. It wasn't until the 9th century that Arabic astronomers described it as red. This historical change in color is not only a reference in astronomical records, but serves as a marker in the star's transformational journey. The fluctuating brilliance of Betelgeuse adds another layer of fascination. It acts as a semi-regular variable star, meaning its brightness goes through periodic variations. This dance of brightness has captivated astronomers and stargazers for centuries. Betelgeuse typically follows a 400-day cycle, alongside a longer 5-year cycle, noted as early as 1836 by Sir John Herschel, and perhaps even earlier in local oral traditions. However, what truly sets Betelgeuse apart is not its shifting brilliance, but its anomaly. Unlike many stars which follow predictable patterns, Betelgeuse sometimes strays from its usual dimming and brightening rhythm. This anomaly points to complex and less understood processes unfolding inside its enormous structure. Recent monumental discoveries have captivated astronomers and stargazers worldwide. When Betelgeuse underwent an astonishing and dramatic change, now widely known as the Great Dimming, everything began in late 2019. At that time, Betelgeuse, the red supergiant shining brightly in the night sky and a prominent member of the Orion constellation, began to undergo a mysterious dimming. The dimming was so striking that it lost brightness at an average rate of 0.01 magnitudes each day, reaching its least brightness by February 2020. Betelgeuse, normally visible to the naked eye even amidst light pollution, virtually faded. Even amateur observers couldn't miss it. However, there's a critical challenge in tracking the activities of Betelgeuse: the time delay. When we observe a star like Betelgeuse, we're not seeing its current state but rather its past. Due to the time it takes for light to travel to us, the light we see today left the star nearly 725 years ago. This time delay complicates efforts to predict and track sudden changes in a star's behavior, as we are essentially observing events that occurred in the distant past. The dimming of Betelgeuse. The dimming of Betelgeuse sparked considerable interest and speculation among astronomers and the public alike. Given the star's immense size and unusual behavior, many feared it might be a precursor to a supernova, a catastrophic event that would signal the star's explosive end. However, as of now, the reasons behind the dimming remain somewhat mysterious. One potential explanation for the dimming is that Betelgeuse could have experienced a massive expulsion of gas and dust, obscuring its surface and temporarily blocking some of its light. Another possibility is that the star's core may be undergoing changes that are affecting its outer layers, leading to a shift in its brightness. Despite these theories, the star's behavior continues to challenge our understanding of stellar evolution, particularly in its final stages. If Betelgeuse were to explode as a supernova, it would be a spectacular event. A supernova of this magnitude could be visible even in daylight, depending on when it occurs. However, such an event would also have significant consequences for Earth. While a supernova would not pose a direct threat to life on Earth, it could affect the Earth's atmosphere, potentially altering the conditions that support life. Fortunately, Betelgeuse is located about 725 light-years away, a safe distance in terms of the destructive potential of a supernova. In the coming years, scientists will continue to monitor Betelgeuse, watching for further signs of its eventual fate. The star's unpredictable nature has made it a fascinating object of study for astronomers, who hope to unlock the secrets of how massive stars evolve and die. As we observe Betelgeuse, we not only learn more about this specific star but also gain valuable insights into the life cycle of stars in general, helping us to better understand the dynamic processes that shape the universe. So, as we await the next chapter in Betelgeuse's remarkable journey, we are reminded of the vast and ever-changing cosmos around us. And while we may never fully comprehend all the mysteries it holds, the story of Betelgeuse serves as a reminder of the awe-inspiring wonders that continue to unfold in the universe, just beyond our reach. Betelgeuse fills in as an unmistakable sign of the innate intricacies in astronomical perceptions and the limits of our comprehension while wrestling with the monstrous sizes of the universe and the time secret. They include the enrapturing journey of Betelgeuse's galactic presentation, which was fastidiously followed by Andrea Dupree, the associate head of the Center for Astronomy at Harvard and Smithsonian, along with her group, utilizing the Hubble Space Telescope. They embarked on a 3-year study to monitor changes in Betelgeuse's external climate. These perceptions gave an uncommon comprehension of how a variable star like Betelgeuse acts with its customary developments and constrictions, leading to fluctuations in brightness. The striking responsiveness of Hubble to bright light enabled the scientists to test the layers above Betelgeuse's surface, which were somewhat warmed by the star's fierce convection cells. Moreover, a detailed examination of the Hubble spectra, obtained at different spans throughout 2019 and 2020, facilitated the measurement of material movement within Betelgeuse's external climate. Specifically, the study focused on the magnesium-2 lines in the spectrum, which offer insights into the star's barometric conditions. These observations revealed material traveling at speeds of around 200,000 miles per hour from Betelgeuse's surface into its external climate. This heated and thick material eventually expanded thousands of miles from Betelgeuse, forming the precursor to the dust cloud responsible for the star's darkening. Dupree and her group estimated that during the 3-month event, roughly twice the standard amount of material from Betelgeuse's southern hemisphere was shed. This significant mass loss is especially notable because, like all stars, Betelgeuse constantly sheds mass, but at a much higher rate than our Sun. The extent of this mass discharge and the subsequent dimming sparked discussions among cosmologists regarding whether this event could signal an impending cosmic explosion. The proximity of Betelgeuse, found around 725 light-years from Earth, adds to the intrigue. If such an explosion were to occur, it would be visible from Earth, presenting an intriguing opportunity to closely observe a cosmic explosion. But the question persists: what does this darkening event mean for Betelgeuse's future? Does it signal an impending cosmic explosion, or is it just a transient phase in the star's immense and complex journey? Various theories have been proposed to shed light on this phenomenon. One theory suggests a phase in the cosmic explosion process, picking up speed due to the widespread belief that Betelgeuse is nearing the end of its life cycle. Another widely accepted theory involves dust, possibly originating from the star itself, blocking our view of Betelgeuse. A third explanation examines changes in the star's photosphere, its apparent surface layer, which could affect its apparent brightness. Thorough investigation using various observational methods contributed to unraveling this mystery. Spectroscopic evaluations showed a decrease in Betelgeuse's effective temperature, indicating the likelihood of a significant dark spot on the star's surface. This theory found support in observations revealing a temperature decrease of at least 170 Kelvin during the darkening period, highlighting significant surface changes. Ultimately, the key to understanding this extraordinary phenomenon came from humanity's careful look into space. The Hubble Space Telescope's precise observations revealed that Betelgeuse's dimming was likely caused by a massive launch of heated material into space. This material coalesced to form a dust cloud, blocking a portion of the star's surface and reducing the amount of light reaching us from Betelgeuse. The formation of the dust cloud was attributed to superheated plasma, which erupted from a large convection cell on the star's surface and passed through its scorching atmosphere to the cooler outer layers. After cooling, this plasma formed dust particles, resulting in a cloud that obstructed light from roughly a fourth of the star's surface. Hubble's ultraviolet light spectroscopic observations, which began in January 2019, played a crucial role in reconstructing the timeline leading up to Betelgeuse's dimming. These observations detected signs of thick, heated material passing through the star's atmosphere in the months preceding the dimming event. By December 2019, other ground-based telescopes also observed the star's decreasing brightness, especially in its southern hemisphere. Initially, this material appeared brighter than the star's usual brilliance, eventually leading to the formation of a shadow as it spread outward and cooled. The concept was simple. This outward progression of material and the resulting shadow were responsible for the sudden dimming of the star. The size of this release is truly remarkable, bringing Betelgeuse into the vast spotlight. The star expelled an estimated 400 billion times the mass typically released in a standard coronal mass ejection. This expelled material was believed to be enough to eclipse our moon several times over, marking a significant event not only for Betelgeuse but also for advancing our understanding of stellar mechanics. But what are the implications of such a massive release of material for Betelgeuse and broader supernova theories? Conventional wisdom suggests that red supergiants like Betelgeuse often shed mass before reaching the catastrophic peak of their existence. However, the size of this release challenges this idea, indicating a potentially more volatile and unpredictable final stage for these stars. Could Betelgeuse be preparing for its grand finale, a supernova explosion in the coming centuries? Later research speculated on the timing of such an event, suggesting it may happen sooner than previously expected, perhaps in just a few years. Furthermore, the concept of the bow shock adds another crucial layer to the Betelgeuse puzzle. As this colossal star races through space at around 67,000 miles per hour relative to its surrounding interstellar medium, it creates a bow shock similar to the wake formed by a moving boat's bow. This phenomenon arises from the star's outer layers interacting with interstellar gases and dust, offering a grand display of the star's dynamic behavior and its connection with the cosmic milieu. But what about Betelgeuse's recent behavior? Its surface cooling and decreased density, observed following the eruption event, leave the star in an unsettled state, even years afterward. Hydrodynamic simulations suggest a connection between the star's convective activities, the mass ejection, and the subsequent changes in its oscillation modes. This ongoing instability raises questions about the internal processes driving these changes and their potential implications for the star's future. Moreover, the observed mass loss rate of Betelgeuse exceeds that of many other stars, reflecting a complex interplay of internal forces. Nonetheless, with energy continually dissipating through shock heating and mass ejection, Betelgeuse's rhythm is shifting. The very nature of these mass losses points to the star's dynamic and somewhat erratic life cycle, prompting astronomers to reconsider their models of stellar evolution.